Okay, so welcome to the course again.
Yeah, thank you.
Yeah, sure. So this is the CCNA 200-301 course, and we just go through a little bit of introduction. But I believe you can see my shared screen too. I've shared the slide. Can you see it?
Yeah.
Okay, sure. Okay, so we can just go in and straight with that. Okay. Sure. So my name is Jesse Okai, and basically I'm a network engineer. I've done this for quite a number of years now. I love to teach, so I've been teaching more, but I still do a lot of field work. Now, basically, this course, I'll try as much as possible to cover the objectives for the actual CCNA 200-301 exams. And the course objectives are available. I think when you get to the website, you can see what the exams objectives are. But then I have them in short here, so you can see. Now, the delivery structure is going to be like this. So we would have either, there are times when we might meet at the center, but I know most of the time now we might be doing online. So we'll do online lectures for every topic, and that's listed in the exam objectives. Then after each topic, we are likely going to have a quiz, okay, from the material we had. So there'll be a couple of questions that you can answer. Then there are flashcards as well. I'll try and get you some, which basically helps you to review what we have learned so you don't forget them. Then we'll be doing a lot of practice labs using either Cisco's packet tracer, or there's another one called GNS3. And then the days where we meet at the center, we are likely going to be using like real devices at least, so because once in a while you should have a feel of it. I don't have too many of them, so we might use the simulators and emulators more. But once in a while, you get to play with the devices as well. So we'll see what we can do about that one. Okay. Then when we are done with the course, we are likely going to have a test for everybody at least. That's the centers test that we do. But then the main idea is for you to actually have the exams now. Those who decide to take the exams, then we can do a further exams prep where we get the jams. Then we try it out for like a week or two. Then you can go and take the external exams. Okay, so this course is for anybody. I don't really care about your background. At least once you know how to use a PC, I'm good to go, right? So that's all I need. I don't need any extreme requirements from you. Okay, because I'll try to keep it very simple for everybody to understand. Okay, the course is divided into three parts. We have the introduction to networks, then we have switching, routing, and wireless essentials. Then the last part has got to do with enterprise networking, security, and automation. Right. For part one, these are the models that we are going to cover. So we'll look at networking today. We'll look at network devices. We'll be touching up on cables and Ethernet protocols. We'll be looking at how do you call it, Ethernet operations, protocol and models, Ethernet switching, data networking addressing, basic router configuration, look at network layer addressing and subnetting. We equally look at some network security fundamentals. Then we set up a little network to play around with. Right. So that's what we're going to cover in the very first part of the course. Now, in the second part, we have more advanced lessons to cover. So we'll still just have a review of the device configuration again. We'll look at some switching concepts. We'll look at VLANs, we'll do inter-VLAN routing, we'll look at spanning tree, Ether channel, DHCP. We'll look at Slack plus SLAAC. We have DHCP version 6. We'll look at the FHRP, LAN security concepts, and we'll look at some switch security considerations. Then we'll look at wireless, right? We equally look at some routing concepts. We do static routing, we troubleshoot our routes and do default routes. Then we can move to the third part, which has more complex topics like you see out there, right? So this is what basically we are going to be covering throughout the entire course. Now, the recommended material for the course would basically be, when it comes to books, we are looking at the books I've listed there. Now, if you can't get them, what I can do is I would zip them. I think I have them in a Google Drive already. I'll send you guys a link via probably WhatsApp or something, so you can download the books and have access to them, so you can be reading alongside. And I would really recommend that you read the books, because if you don't read, there's a lot of information in the books to read. I know they are voluminous books, they are quite big, but then if you can read, then we can actually go faster, and it makes you understand what is going on out there. Because I'm sure most of you are new to this thing, but then the only way you can get the knowledge is actually to read. For useful links you can actually visit to get some extra knowledge are the ones you see there. So you have free CCNA workbooks. You can find a couple of labs that you can try your hands on. You have CCNA 6, which also has a lot of labs. Then you have GNS 3 volts, which also has tons of labs that you can actually work around with, right? So that's all that it is for the course for us to do. Now, what I would do is for every lecture we have online, I'm going to record the session. So if for some weird reason, maybe you're not able to join, or maybe there are some technical challenges, so you don't really get too much of what is happening, I'll put them on my YouTube channel, so you can always go back and revise them or watch them. But it won't be there forever. Maybe it might be there for a week or two, then I delete them. So that's basically what we are going to do. I believe is it okay for everybody?
Yeah, yeah. Okay.
Okay, sure. Okay, no problem. Good. Okay, so let's go and straight and uh, start our class. Let me start with the very first thing. Okay, for the first model, which is networking today. Okay, wait, let me see something. Do I have anything in that one? A minute. Okay, there's not really a slide on it. What basically it tries to look at is it tries to look at the various trends that are coming up in our networks. You realize that the industry is changing. It's not like the first, how it used to be very hardware based. You'd have to be hardly configuring devices and stuff. But then we have so many new trends coming up. Like you look at IoT, you look at things like software defined networking and stuff. So it should tell you the network industry itself is changing, and so many things are driving it. So it's a responsibility for us to kind of learn and get in there, right? But as we go on, I'll be chipping in some of them. So let's start straight with network devices. Okay. So introduction to networks, right? And specifically, we'll be looking at network devices for this particular lesson. At any point in time, if I'm saying something you don't really understand, I think there's a raise hand button somewhere. You can always raise your hand, you ask your question, and then we go on with the class, right? Or you can maybe send it as a chat, and I'll respond to them promptly. Okay, good. So network devices, right? Our network comprises of so many devices, like the diagram you see there. It's made up of so many things. And I'm sure some of us might have come across things like this before, or diagrams like this. Sometimes you don't really understand what they are, right? But then for us to understand what networking basically is, I think it's fair enough. It's fair enough before we start talking about network devices, it's fair enough that we actually see what a network is. At least once you can understand what a network is, then all these pieces would basically fall in place. Okay. So if I may ask, what's a network? Like we have all heard this before. So if I may ask what a network is, can anybody say something? Are we there?
Yeah, yeah.
Yeah, so I'm sure that it's not a new word. So if you can say something small, like tell me what a network is from your point of view, you understand it. Okay. So let me just go on. Let me borrow a definition of network from Wikipedia. Now, when you look at Wikipedia, it basically tells you what a computer network is a group of computers that use a set of common communication protocols over digital what connections for the purpose of
Bravo.
resources located on or provided by the network what nodes. I think I might end it there. So that's what basically I'm interested in. So it's more of what a computer network is a group of computers that use a set of what common communication protocols over digital what
My
interconnection.
refuse me. Yeah, we be online.
Right.
Yes,
Over digital
thank
interconnection for the purpose of
I didn't.
sharing resources.
You want to
Okay.
listen? Break ban.
Right. Good. So when we look at what this definition basically tries to tell you, it's saying when we look at a computer network, it's just basically a set of devices we are using. But then for us to understand these things, let's look at other things. So for our network, it will basically comprise of a few things like a router, which you see there. And for most of the class, we'll be representing a router with this particular image you see down here. Most of the time, that's how we would represent our routers. Now, your network would equally be made up of switches. So you're likely going to see switches here. And then we have firewalls, which we would equally talk about and see what they basically are. Then we have client devices or servers. We have servers basically. So you have servers out there. Then we have client devices, right? Now, usually these are the main devices you would find in any given network, but then there are other devices as well. So it's not restricted just to what you see here, but there are so many other devices that make your network a network, right? Now, for these two things, like a client and a server, usually they have a common word you might see people refer to them as. And you might either hear people call it an end host, or you're likely going to hear them call it an endpoint. So these words can be used interchangeably for either a server or for a client. Right. Now, let's try and get more into the definition of a network by examining the PCs we have basically there. And that will let us understand it more. Now, when you look at what you see on your screen, I have PC1 here, and then I have PC2 here. Now, this is not a network. As it stands, these are autonomous systems on their own. Like this computer can do all it has to do directly on it. This other computer can do whatever it has to do on it. But there's no way they can actually what? Communicate. But the moment I introduce something new, like a connection, like the cable you see here, everything changes. Now, once there's a connection between the two of them, what it basically means is this PC should be able to what? Send information to the other what? PC. And that is what brings us back to the definition. You can see it says a computer network is a group of computers that use a set of what? Common communication protocols over digital interconnections for the purpose of what? Sharing resources. So you should know before I can say I have a network, there should be something connecting the two devices what basically together, right? Now let's proceed forward. Now when we speak of clients, now let's look at the various devices we have. Now when we look at clients, right, clients can be anything. So we have clients that might comprise of things like our laptops, which we use all the time. We have clients that might comprise of what? Our desktop computers. These are all clients. Now, if I have an iMac, it's equally a client. My phones are clients. We have other things like IP cameras, we have tablets. All these things are what? Are clients on our what? Our network. So we can't restrict clients to just one specific thing. Now, mostly when we want to define what a client basically is on the network, this is what we look at. A client is any device that would basically access a service or a resource that is usually provided by a server on a network. So any device you have on your network that is accessing a resource provided by something else. Okay. Right. So once you see any resource that they are once you have a client that is actually accessing resources on the network, that's how those are the devices that we call what our clients for that matter, right? So any device that would access a resource is a client. Now, when you come to servers, on the other hand, is the exact opposite of a client, though it is sometimes fairly related, in the sense that a server can be anything from the complex devices we see like this. So you have a Dell server sitting there. That's another Dell EMC server. I know usually when we hear server, that's what comes to mind. Very bulky, sophisticated systems, right? And that's true because for them, I'll call these are hardware servers, like you see, it means they are built as servers. Okay. But more of when you really want to define a server, it is any device that is basically providing a service or a function to clients, right? So I can have dedicated systems like what you just saw as a server, but then I can also have software defined servers. So even my laptop or your laptop can end up as what? As a server. The server client thing is defined by what the device is doing on the network at a particular moment. That is what gives it the name as a server, though you can have dedicated server equipment bought, right? So let's look at the scenario we have here. I have PC1 on one side, and then I have what? PC2 on the other side. Any of them can end up being what? A server, or any of them can end up what? Being a client at any point in time. So let's say if PC1 has a file it wants to send to PC2, at that moment it's a server. PC2 becomes a client because that is what is accessing it. We'll see an illustration of it pretty soon. If we look at this scenario here, which is the way most of us would understand this client server thing, most of the time you have your PC and then you're browsing the web, right? So if let's say you go to a website like nzurisystems.com, it is hosted on a server somewhere. So your PC tries to what? Access that particular website from over the internet, right? We'll look at the internet later on. It's an entire network on its own. It's quite complicated, right? So you realize that the PC goes out there to fetch these things. So your PC can say, oh, give me the website, the web page. Meaning your PC is requesting for the web page from the server out there. Now the server then tries to what? Respond by saying that, okay, you can have the web page and sends you the web page from the internet. You get it? So this is a typical example of a client server scenario where your PC is accessing what? A resource which is hosted on a server sitting somewhere, right? Now, let's use our phones since that's what most of us spend our time on. Now, the same thing applies to a phone. And the common way we tend to do it is with the phones, we tend to do it with our what? With our Bluetooth, right? So let's say I have a picture you want, okay. Now, the moment we turn on our Bluetooth, we pair together, we have set up what? A communication link. And I can actually what? Send you the picture. So if I send you the picture, in this case, I end up being the what? The server, you end up being the what? The client. So that's what I want you to have in mind, that when we hear the word servers and client, it is a very relative term. What you are doing on a network at a particular time determines whether you are a server on that network or you are what? A client on that particular that network. Right? Is the explanation clear?
Yeah.
Okay, sure. Yeah, that's good. Okay. So now let's proceed and look at switches. Let's see what they basically will do for us. So we have an amazing network. You see there, right? So we have switch one, and then we have switch two sitting somewhere. Now, usually, our switches tend to be devices that have multiple ports on them, which allows us to what? Connect devices together. I always tell people your switch is what actually defines your network. You get it? If you look at the previous examples, it was just direct connection. So it's one-on-one thing. That kind of scenario, we actually call it a peer-to-peer network because the devices are not playing. It's just maybe one on one or one and a couple of devices. But when you look at a full-blown network in an organization, most of the time, you don't have just one PC, but then you have maybe 2 or 3 machines out there which you want to connect. You can connect them together. You need a device to handle that entire connection for you. So a typical switch looks something like this, right? So you can see a device there that has what? Multiple ports on it, okay, which allow us. So that is a typical example of a Cisco Catalyst switch, okay. Now, all that switches can ever do is to connect devices within their um, their own domain. So if you see here in the Accra branch, this switch can only what? Forward frames from PC2 to PC1, and that's all it can do. It would never be possible for a switch to forward a frame to another switch somewhere else over the internet. It doesn't work like that. So like this internet cloud you see here, my switch can connect directly to the internet or can connect directly to another network. Switches do not do that. Okay, they would never do a thing like that. Now, in the class of devices that do things like that, a switch basically happens to be the third generation of devices that do that. That's basically multi-port devices that allow devices to connect to them. The very first ones that came was known as a hub. Okay, I don't know if you've heard of it before, but then we used to have hubs. Now, hubs equally had multiple ports on them. They allow devices to connect to them to form a network. Just that they do not work very well. So we have stopped using them in the sense that we'll look at collision domains later on. But a hub happened to be a single collision domain device. So it had effects on speed and so many other things. It wasn't a very effective network. Security wise, they were not very the best devices anybody could actually use. Then we came to bridges. Bridges were amazing devices. They were good because then they were not a single collision domain. They were breaking collision domains out there. But then they were doing that from a software perspective. So they became very expensive because then if I want a bridge that had a lot of ports on it, it will cost me a lot of money. Right? And that is where switches what basically came about. Because with switches, they equally break collision domains, but then they do it what? With a hardware standpoint. They have something called an ASICs inside the switch. And the ASICs is basically what allows a switch to be a switch and do everything that switches would basically do, right? So if you look at some of the typical characteristics you would find on a given switch, a switch is likely to have a lot of interfaces on them, what you might otherwise call ports. They're actually called interfaces. So you might have a lot of interfaces on them. The least amount of interfaces you can find on any switch is likely going to be what? 4 interfaces, right? Now, also, they provide connectivity to hosts within the same LAN. Like I said, that's what your local area network. So devices connected to a switch can only communicate among themselves. They can't go beyond that switch. Okay. Even if you stack up switches together, it is still one local area network. So have that in mind, right? So don't think that my switch can link me to another network, let's say over the internet. Switches will not be able to do that for you. So they do not provide connectivity between LANs or what? Over the internet. Okay, we would demo some of these things and then we'll see how it basically works out. Okay, so up there you see various types of Cisco switches. So that's your Catalyst 9200, that's a Catalyst 2960, and the Catalyst what? 3650. These are all different switches. As we proceed, we realize that we have what? Different types of what switches. So let me even speak of them. Now, when we look at switches, we can have switches that fall into the category of L2, what we call layer 2 switches. Now, layer 2 switches, it means what they can do is just switching. Like they have plain switching features, that's all. But then when we talk of L3 switches, these are switches that can actually do an amount of what? Routing. I've not spoken of routing yet. That's why I didn't want to talk, but then they would get to understand them as we go along the class. So this is our previous diagram we have. And we already know that there's no way this switch here, that is in the Accra branch, there's no way this switch can pass on anything to the Lagos branch. Switches are not allowed to do that, right? If we want to send anything across, then we'd have to introduce something else. And I know some of you are already guessing. Your guess is likely going to be right. So we have what? We need to introduce routers. You get it? We need to introduce
Yeah.
what? A router.
Route.
Yeah, so before we can move anything from this Accra branch all the way to the Lagos branch, a router has to handle that for us. The reason being that routers connect different networks. Okay, so if you look at this Accra branch, it's a network on its own. If you go out there to the internet, that's a different network on its own. So routers have the capability to do that for you. So they connect different networks together. That's the only way we can move any data across. We have so many different types of routers. So we have something like the ISR 1000, that's integrated services router. And there's a small router that's geared towards small businesses like SMBs. You can have this. Now, I know you'll be wondering, how come this one has so many ports in there? I'll explain to you shortly. But there's the ISR 900. And then you have the ISR 4000. These are bigger routers for much more bigger um, companies. Okay. Now, this you see here is a router, but at the same time, it has switching capabilities. Okay, so it is geared towards small businesses who don't have all the money to buy huge devices like this, but then they want enterprise grade features. So I go for something like this. It does good routing for me. It has support almost all the Cisco protocols, but then I also get 4 switching ports. So what you see here are the switching ports. Then what you see on this other side happens to be the routing ports. There's a console port. We'll look more about that when we go on. And if you would want to compare it to the switch, realize there's a vast difference. Okay, so usually visually, if you want to identify switches from routers, that's one of the easiest way to do it. Just by looking at the device and looking at how many ports you see, lets you know whether this is actually a router or it is what? A switch. Right. So that's what we basically find with devices like that. Okay, so let's look at some main characteristics of our um, routers. So they have fewer network interfaces than our switches, and they are used to provide what connectivity between LANs. So the moment, let's say you have one network on one building, you have another one on another building, and you're thinking of how to connect them, the only thing that should come to mind are what? Basically routers, okay? And I therefore used to send data what? Over the internet. So anytime I want to go out to the internet, I know my switch can't connect directly. I would need to introduce a router into that particular word topology, right? Now, the same topology we have, but then this time around, something else has been introduced. This guy down here, an attacker. Security means everything to everybody, right? So we started our network fine. It used to be a very small network like Accra. Eventually, we opened the Lagos branch. We had to introduce what? Routers. But then a new threat emerges. We have people out there on the internet who are likely what? Just lurking around, waiting to harm your network, probably steal data from these servers you have in Lagos. Now, how do you mitigate something like that? Now, the only way we can do that is by introducing something new, which we call the what? The firewall. So firewalls basically allow us to secure our network by filtering the traffic that goes in and out of our network. They come in so many variants. Now, if you look here, there's a typical example of some firewalls that we have. So there's a Cisco ASA 5500 is the X series. That's how they look like. And then you have the Firepower 2000 100 series. These are all different firewall brands from Cisco. Now, what firewalls would basically do for you is they monitor and control your traffic based on what configured rules. So what you tell your firewall to look out for. So maybe you tell your firewall don't allow any FTP traffic into my network. So as soon as it sees FTP traffic, it blocks it. You decide what your firewall is supposed to do. By default, firewalls are stateless devices. They block everything until you start configuring them. Okay. And you can place your firewall anywhere, but you have to know what you are, because everywhere where you place your firewall determines how the firewall is actually going to work. So I can either place the firewall inside my network, or I can place the firewall outside my network. Let's go to the previous slide. You see here, when you come to the Accra branch, this firewall is outside their network. You see where the firewall is? It's after the router. But then when you come to the Lagos branch, this firewall is what? Is inside their network. So what that means is, if you come to Accra, if this attacker is trying to attack anything here, his traffic is not even permitted inside the network, which means the firewall is even going to what? Block it. It won't allow it to go through at all. But if you come to the Lagos branch, because their firewall is inside their network, it means this attacker's traffic is likely going to pass through the router before the firewall what actually blocks it. It has its own what implications. Yet it has its own implications. So per your needs in your organization, that will determine where you want to put it, because then they all have their benefits and all of that. Okay, kindly hold on for me a minute. Hi, yes. Good morning, no. Oh no, no. This can I call you back? I beg. I'm having a class online. I'll call you when I'm done. I'll call you soon. Okay, thanks. Okay, sorry about that. Sure. So we have this. So that's the scenario, right? As we go on with the class, you see why you might have to place your firewall either in front or what, or at the back, right? Okay. So that's firewalls for you. Now, I know you might hear the word next gen. Okay. Now, most of these firewalls you see, these are all plain firewalls that will just be looking at your traffic, filtering it in and out. But then there's a new word on the blog these days. You always hear people say there's a next gen firewall. Now, we only call firewalls next generation if they include more advanced or more modern advanced filtering capabilities. Okay, so which means now they don't just look at packets and then they stop them, but then probably they have features like an IDS embedded in them. That's an intrusion prevention system, or they have something like an IPS, that's intrusion prevention system. Then they have IDSS, that's intrusion detection systems. Okay, so these are things that a firewall is likely going to have for it to be called a next generation firewall. Okay, good. So if we look at our firewalls in general, we have two main types of firewall, because most of us, this is the first time all of us are hearing firewall. Those who have our PCs realize that sometimes even on your PC, you see Windows firewall and stuff like that. Where do we put these kind of things? So we have network firewalls. Network firewalls basically tend to be what? Hardware devices, like you see up there, which can be placed inside your network to filter traffic. Then we have host-based firewalls. These usually are not hardware, but they are embedded usually into software applications like our operating system. So I have something like a Windows firewall or even my antivirus software. So most antiviruses would have a firewall feature embedded into them. And Windows itself also has what? A firewall feature embedded into them. So in as much as we can put network firewalls in our network, it is also very, very important that you should still have what? Host-based firewalls, so that just in case an attacker is able to craft his packets very well and it bypasses your firewall, when it hits the host also have a layer of defense to help them with secure themselves. That is why we install things like antiviruses, like the endpoint securities you have. That's why we do things like that, right? So I believe this has been very clear. Have you understood what we have gone through in this particular model?
Yeah.
Okay, so I hope it hasn't been very complicated. It's been simple, right?
Yeah.
Yeah, so now if you should see a switch, you should see a firewall, you should see a router, you hear of servers, you hear of clients. I believe you know what role each one of them plays on any given network, right? Because these are things we would be encountering all the time. Okay, so this model has come to an end, but then before we go, let's have a very short quiz. So you can text your answer since we are about 4 here. You read the question and then you text your answer in the chat. So we look at it, but then we'll still discuss it though. Okay, so that's the first question. So you put yourself in that shoe and then let's see how we can answer them. So a company has 20 PCs in a department. They are considering purchasing a new network device to plug them all into. What type of network device would you recommend? And you have your answers there. You have a router, we have a switch, okay. Okay, okay, so, okay, good. Okay. Yeah, sure. So you're all correct. So I believe the answer is going to be what? A switch. You get it. So once they are saying, because we all know routers do. Routers, first of all, don't have so many ports to be able to accommodate 20 PCs. You get it. Firewalls equally do not have a lot of ports on them. They just usually have a few ports for it to connect your switches to. I think the maximum I've seen on most firewalls happens to be like 4, so you don't have a lot of them on it. Then servers too, we know you don't have ports to serve any purpose for that matter, right? Now, the second question says you are tasked to connect separate networks together. What type of network device would you use? So for the second question, for the second one, what device would we use? Okay. Okay. So yeah. Okay, sure. So we are all correct. The answer is what? A router. You get it? Because we said router is the only device that connects two separate networks together. So that's what we basically would be using for most of the time. Okay, so I think we have 2 more questions, then we can round it up. Right. So we have a company wants to upgrade its old network firewall that has reached its end of life. They are considering purchasing one with more advanced functions. What kind of firewall would you recommend? Okay. Okay, sure. So you're all correct. So the answer is D, right? So next gen firewall, right? So once you are saying anything with advanced features, it's called the next generation firewall. So now the last question, it says you are tasked to connect separate networks together. Okay, now this is repeated, right? Sorry, I think I have to change it. There should be something else, but it's equally what a router, right? Sure. So this is how our class is basically going to be like, and that's how your exam questions most of the time look like. For some scenarios, you might be required to choose 2, like multiple answers. In some, it might just be 1 answer or something like that. But it's not always easy. But this is a very easy topic, so that's what happens. Now, for the lab work or the lab assignment for this particular model, our task is to draw this particular topology you see inside packet tracer. Okay. Now, for those of us who already have packet tracer, I'm sure we know how to use it. Those who don't, let me quickly take you through how to download the packet tracer um, application itself, but then you just find a way around it. Okay, so okay, I'm quickly going to do that. But then you can probably take a screenshot of this lab because you would still end up doing it. So take a screenshot of it, then you would see how to do it. Okay, so
Hello.
yeah,
Hello.
yes, I'm here.
Yes, yes. Can you come again with the last instruction you just gave? I'm in two meetings, so
Okay, Lauren, I'm saying you should take the lab. You should take a screenshot of this lab or something because you draw it
okay,
inside packet tracer. Yeah,
okay,
yeah. So you can take a
okay,
screenshot, or you try and draw it on paper, then we'll reproduce it again.
okay. All right, that is done.
Okay, sure. Fine. So I'm going to quickly pull up my browser. So I show you how to get packet tracer. I don't know if Ransford already has it, but it's likely you
I
might
don't.
not.
Yeah.
You don't have it, right? Sure. So let me
Yeah.
show
Oh.
you how to download it. Now, so I've put my browser here. Now you can just open Google and search, though I don't really recommend that method, okay? But you can just search packet tracer.
Wow.
Sorry. You can just search packet tracer. Good. So when you search packet tracer, it brings you here. I think there's a link I was looking for. The very first link you see is Cisco Packet Tracer Network Simulation 2. Now you click on it. Now it's a tool provided by Cisco themselves. Okay. And before you can actually download this tool, you should register for a course. So this is Cisco Network Academy. Okay. Now, when you land up on this particular link and you scroll down, you can see this here. You have a self-paced introduction to packet tracer, right? So I'll just click on it. Okay. Once I click on it, then I can sign up. Today is down there. You get it, and it's English we want, so we sign up. Now, when you click on the sign up, it gives you this page here, which you are likely going to, you'd have to submit. Okay, so let me just use a dummy account to do it. So I just put in my name, then let me use, this. Please, and I don't want any of that. Then you have to agree to the terms. I certify that I'm 13 years old and above. So we do simple math. 11 plus 7, that's 18. We put it there. Yeah. Then we submit. Okay. Okay, why? They say my answer wasn't correct. How is that possible? 5. Okay. So it's just you just have to sign up with them, which I recommend you do actually. It's not a very lengthy process, though they are making it look like one. But then you choose your country. So I think I have Ghana here. Then we create a password. So, okay, so the password has to meet some complexity level. So let me just do L. And you put whatever they are showing there. take you less than 5 minutes to do this actually. So 002 like this. Then would you like to update? No, I don't want any of this. Then all I have to do is what? Register. Okay, so once the registration is done, it's going to ask you to sign in. Once it's done, it's going to ask you to sign in. So I think the account I used was Chesiokai at Nzuri. So I sign in. And then I enter my password. So it will be these guys. So when you do the sign in and everything, they will send you a verification code to your mail. Let me quickly pick out the code and see. Okay, I didn't receive the code, but I think they should send it soon. Okay, so they'll send you a code to your mail, which they sent it. So let me quickly enter. So it was 378789, like that. Then you verify. Really? Wrong code. How is that possible? Okay, I'm sure because I requested again. Okay. Okay, so it's okay. So it's 959,717. Good. So once you are verified, okay. So once you are verified, you just complete the form. It's just a lot of things, but within 10 minutes, you should be done. Your gender, country, Ghana, state. You don't really need to complete all of this, but then, no. If you want to put your date of birth there, I think you might have to. If you don't, it is not going to work. Fine, so okay. So I think it's done. Once you've selected everything properly, you should be able to have this. Okay. So that's it. Then you just choose. I'm done. Then you can launch course, but I don't launch the course now. Once you are done with everything, this is the course you have with them. Then you can just click on resources, then download Packet Tracer. So you have various versions. Per which machine you use, it would pick up. So I have Windows here. So if you are using a 64-bit Windows, you select that. If you are using a 32-bit Windows, you choose that. So as my machine is a 64-bit, so I just have to click on what? Download, and it downloads it for you. Now, they equally have a mobile version of it. So it's available on iOS and Android, but it's not something I recommend you use often. Maybe just you're on the go, you want to try your hands on it, fine, because the phone screens are pretty small and it's not really easy using it actually. But if you want, you can always give it a try. So it would download here, and then once it's done downloading, all you have to do is what? Is to install it. I believe you can do this, right?
Yeah. Yeah.
Yeah, so you just Google it and then you just go through the steps and then you download it. Then you can get the latest version installed on your PC, right? Um, I already have it downloaded and I already have it installed. So we can leave this and let me just open it for you to see how it looks like. Okay, it's coming up. I'm not show you. Okay. Now, when you launch Packet Tracer, this is what happens. It gives you a login screen, like you are seeing here, me drag here. It gives you a screen like this. Now, if you didn't do the registration with it, that's the reason why we do it. If you didn't do that registration, you won't be able to use it. You might have to use it in guest mode. In guest mode, you can't save any work that I think you have up to a maximum of 5 saves. After 5 saves, you can't save anything again. You get it? So that's why you need to create an account with the Cisco Network Academy, and then you can use it here. So you always have to log in when you start, especially if you are connected to a network, this will pop up. But if you are not connected to a network, it's likely not going to pop up. So if you have internet access and it pops up, you just put in the same email address you used when you were downloading the packet tracer, and everything should be fine. So let me quickly just let me log in. So let me log in and drag the packet tracer here. Okay, so okay, fine. So it's done. Now I can bring packet tracer here for you to see. Right. So once you install your copy and everything, this is what you are likely going to get. Okay, so this version 7.30. Okay, so depending on what you download and what you're going to get, but you're going to get an interface similar to this one. Right. Now, let me just explain the interface here for you so that you know what you are doing and what you are working with. Now, most of the time, we'll be working with this on this bottom pane here. That's where you have all your devices. Okay, down here, you have all your devices and they have been put into various categories. So you have routers, so you have category of network devices. You have end devices, that's the next one that follows. Then you have components, right? Things like models and boards and stuff like that. Then here, these are your connections, the cables you'd use to connect to devices together. Then you have other miscellaneous stuff. You have the cloud multi-user things there. But for most of our class sessions, we are going to be picking devices from network devices, you're likely going to be picking things from what? End devices. Then we'll be using what? Cables. Okay. So when we select network devices, it gives us all the things under network devices. So under network devices, we have routers, we have switches, we have hubs, we have wireless devices, we have firewalls, that's security, and then you have WAN emulation, that's cloud, ADSL modem and stuff like that. Okay. But for now, we are going to be playing around with what? A router. Now, when you want to drag anything, so when I click on a router, it gives me a list of different platforms. Cisco routers come in various platforms. So here you have the 4331, 4321, 1941, 2901, 2911. So many different types of routers. Now, each routers have their own capabilities, like the interfaces they come with and stuff like that. But for now, since we are just starting out, I'll just pick the 1941, which happens to be a very basic router. So to pick a device, all you do is you can either drag and drop. So I click on the device and drag it to the workspace you see here. Or I click on it. Once it is selected, I come to my workspace and click on it. Then I have the device there. You get it? Right. So I'm going to draw the topology we have, the topology I said you should draw. I'll just quickly draw it here for you to see it. So I've picked up two routers, and that topology comprises of what? Switches, right? So I click on the switch, and for most of our class sessions, we'll be using the 2960 switch, okay? Then there's also a 3560. So 2960, I just drag, put one here, then I drag and put another one there, right? Okay, like this. Then we had two PCs and some servers. So I go to end devices, I pick up two PCs, I drag them here. Then I pick up a server. On the other side, we had servers. So we have a server here. So I put the server here. Then I put another server there. All right. Now I think we had firewall too. So this is a firewall appliance. I can just pick one firewall, place it. I think this one, they had their firewall outside.
Also,
Yeah, and then these guys had their firewall inside. So
inside.
yeah. So I put it there like that. So now we have selected all the devices we want. And before we bring the cables, let's label them properly. You see, by default, it picks PC, gives it 0, that kind of a thing. But then you might want to change it to their respective names. You realize some of them were named R1, Switch 1, those kind of things. Now, for you to be able to do that, you go to Edit here. No, sorry, you go to Options, and then the Options, you have Preferences. I guess you can see it. Options, Preferences. You select that, and then you can change the names you want to show. So you realize you have what? Show device model number. So I just uncheck it. It will take the model number off, and it will be left with the name alone. Okay. Then you would also check on this. There's one more thing I'm looking for. Port labels here. You also have to show port label so that when you connect the cable, you can see the port numbers because we would use them for most of our class. So once you are done with that, I can clean it. So realize now we are left with just the names. If I want to edit the name, I just have to double click on the name. So when I double click, I can put whatever I want here. Switch 1. And I can change this to R1. You get it? R1. So that's how we relabel all of them. I think this was firewall 1. So FW1. Okay, then PC. So that's how we relabel it. So you can relabel all your devices effectively. And this was R2. This was firewall. Sorry. This was FW2. And then this one was, yeah, sure. You get it? So that's how we relabel them, and then server 1, server, stuff like that. Now, once we are done, let's connect cables. But then for now, since we haven't spoken about, I've not taught you about cables yet. So you see this Thunderbolt, this lightning icon. All I do is I click on it. Now, when I click, it gives me so many different type of cables. But for now, just for today's class sake, I would use the first option. This one is automatic cable selector. So when I choose this, per the device I choose, it decides, it automatically figures out what cable it has to use. So I want to connect the PC to the switch. So to connect, I click on the PC. Sorry. So when I click on the PC, I just drag to the switch and click it connects. So now if you don't want to be coming back and forth to pick, when you are selecting, keep your hand on the control. Then I don't have to come back again. So I select this, I come, I select, it connects, I select, it connects. I didn't bring the cloud, I'll bring the cloud soon. So I connect this to, it connects like that, connect like that. Now I press escape to release it. Let me bring the cloud. So devices, and then one emulation. So let me just pop up a cloud here. Like that, right? And I'll name this internet. So I name this internet, and then I go back again and choose the cable automatically. So I pick again, sorry. Okay. It seems the cloud has just one, it has just one port. Okay, that's why. This one is on Ethernet. Okay, so let me just bring one more. No, I'll explain this to you. I'm just trying to insert a model. It has just one port, so it's not allowing me to put it in there. So let me put this in there. And I turn it back on. I think I should now be able to. Oh, I still can't connect. Okay, this is Ethernet 6. Can you imagine? I'm coming. Fast Ethernet. Okay, sure. So let me quickly put this here. I hope this time it works. Okay, sure. So it works. So that's the kind of connection we all have, right? So that's how we do. We will draw a quick topology and everything out there, right? And you can see we have the model, the interface numbers attached to them. So you can see on the router is connected on gigabit 0/0. We speak more of interfaces, but then what you see there are the port labels. Every port on a device actually has a name. And that is how we will configure them. So if I click on a router and I want to configure, I should know the name of the port or interface on which the connection was made. Then I can use that name to configure that particular interface. So that's how we can draw a very simple topology inside Packet Tracer. Now, for now, I know I can't teach you everything Packet Tracer today, but then what we can do is let's save it. Along the line, it's still a learning curve. We'll be learning more extra features about it. But for today, what I would want you to do, those who don't have it, you try and, like I showed you, you get to NetAcad, you create an account, you download your own copy of Packet Tracer, you install it, and then you'd create the topology, just like I have done. Now you can save this, right? To save, you just go to File, and then you save, just like you save most of your work, right? So you save it, and I'd prefer you create a folder somewhere on your PC. So as you're learning, you know where you're learning and stuff. So you can create a folder, and I can name it, I'll name it labs, basically. So It can be your name and labs. Then we just open it. Then I give it a name. So this was this was lab 1. So you can just name it like that. Maybe lab 1, network devices or something. Then you save. Okay, because when you do this assignment like this, and I'll create a Google Drive, because when you do it and I want to check it, all you have to do is you drop it into the Google Drive so that then I can also have a look at it. So that's it, it is saved. Okay, and you will find the file. If I go to my, I created a document, I think I put it in my documents, right? I created a folder called labs. You can see it there, lab 1. So if I wanted, if it was an assignment you did and you want to send it, you just go to wherever you saved it and then you copy it, probably share it to the Google Drive or send it via WhatsApp or something, and I'll get it, right? So I believe this has been very clear.
Yeah. It's clear.
Okay, sure. So please try as much as possible to equally do it, because this is where we'll be doing most of our practices. Since real devices are expensive, so the only way you can actually do all your practice is by using Packet Tracer, and it does almost everything. The only thing Packet Tracer won't do, which is where GNS3 has an advantage over it, there's some commands you can only enter them on live gear. Some of them will not work in Packet Tracer, but this is a new version. I think they fixed most of those issues, so it should be able to serve us throughout the entire class, right?
Okay.
Okay, sure. So today's our first class. I think we might end it here today, but then God willing, when I see you guys tomorrow, we continue from there. And I hope the time works for everybody.
Yeah. It's okay. We'll manage.
Okay, yeah, sure. So we'll try. But then I'll send you the link for the books, so you can download the books as well, so you can start reading.
Sure.
And then you try and do the assignment and all of that. If you have any challenge, kindly contact me, right? If there's anything you need extra explanation, please do. And I'll post this on my YouTube channel as well. So if there was any part you missed during the class, you can always go back to the channel and watch it out. Okay.
Okay.
Okay,
So
sure.
the course it will take how many weeks? 4 weeks, huh?
Depending on the way we go, but then usually it's supposed to be if you're going to stick like this, I know it should be about 6 weeks or so, so we should be done, or less, because once we exhaust the material, we are done, right?
Come again.
Yeah.
Come again.
Yeah, I'm saying it should probably run us around 6 to 8 weeks. If you're doing 2 hours, yeah, because we're online, I'm sure we should be able to run it up.
Okay.
Okay, sure. Okay. So we'll get in touch then. So I'll see you tomorrow, right?
Okay. Thank you. Bye.
Okay, bye.
Hello.
Yeah, all right.
Yes. When next are we having a class? I don't have the schedule.
It's tomorrow. We are meeting Monday to Thursday. It's 4 times in a week.
Monday to Thursday.
Yeah.
Okay.
Yeah, 4 times a week. So we can.
That's fine.
Yeah, sure. So I think we are on the group page or something like that.